And please know, Socrative is not for points. It is just for review and to kind of go over some things. So don't be stressed out if you don't know the answer. Take your best guess. All right, one last time for those of you joining in, please go to joinpd.com and type in that code ZMSXN. That's how you're going to follow along on the lesson today. So once you get onto that joinpd.com, it's going to tell you to go onto Socrative.com. This is just our review that we do right when we start every lesson. You can join anytime, even if you've missed a question. That screen is going to be up. And we're going to do last week's questions and a few other questions. So for those of you that are on the Socrative, go ahead and answer your first question. And then we're going to move ahead here in about 30 seconds. But feel free to jump in anytime, everybody. It doesn't matter if you start at question 1 or question 8. So the first question on Socrative today was, why do you think biologists want to classify organisms? And the correct answer was A, to show how related organisms are to each other. So we'll move on to question number 2. What do biologists use to help classify organisms? And once again, for those of you just getting on, go to joinpd.com, type in that code, and then in a different tab, go to Socrative.com. Room name is Radnich Bio. And it does not matter what question you jump in on. This is not for a grade, it's just for review. And awesome, a lot more of you are getting onto Socrative, which is great. We'll do this every time, so it'll be easy for you to remember the next couple of times you get on. All right, so most of you said that we use that dichotomous key, which is that kind of weird looking tree that we've been creating the past couple weeks. For those of you that are new, you'll be moving on to that classification assignment super soon. Right now, you guys are doing a lot of scientific method stuff, and we'll review a little scientific method stuff as well. All right, so here's our picture of our dichotomous key. So what separates the birds from the rest of the organisms? And we're going to move a little fast through these because these are old questions. We've gone through them already. All right, guys, make sure you get on that Join PD. I see a lot of you have connected, but some haven't yet. That's how you're going to actually interact with us in the lesson today. Okay, so most of you guys said that feathers are separating the rest of the birds from the organisms. Very good. Next, what is the major difference between fish and amphibians? What is the major difference between fish and amphibians? Wow, some of you guys are fast. I think next week I'm going to try to remember to play some like background music while you guys do this. Okay, so on that key, it says that amphibians will not have gills as adults, but our fish do. Very good. Okay, this is a little bit of a tough question. I know we went over it last week too, but what is the term used to describe how we classify animals? Okay, good job. Most of you guys remembered it is taxonomy that is used is the term that we use how to describe animals. Good job. Which of the following would be a correct observation about the animal? Good job, guys. Most of you said B. It has large, sharp teeth. It's just a little bit more descriptive than those other ones, which can really kind of mean a lot of different things for a lot of different organisms. When looking at this classification pyramid, which is the most specific in classifying an organism? Specific in classifying an organism. Remember, if you don't know, it's okay. This is why we do this kind of stuff. Especially those of you that started this week, you'll move on to classification stuff here in a little bit. Make sure you go back and watch those scientific method videos too. All right, nice job, guys. Most of you said D, species. Yeah, species, that very top little part of the pyramid. That's the most specific we can get. Kingdom is our most general. And then it goes up from there. So a species would be super, super specific. Kingdom, I mean, we can have kingdom animale, which is every single animal on Earth. All right, here's our new questions. We finished off last week watching a super short video, and we talked about different ways to kind of classify organisms, different terms you can use, and one of those was a producer. So which of the following would be considered a producer? All right, most of you said grass. Very good. Grass is a producer because it produces its own food. That's why it is a producer. If an organism is a carnivore, what does that mean? Wow, you guys remembered this one or already knew it. Carnivore only eats meat. Last question. What type of organisms need to eat organisms to gain nutrition? All right. 90% of you said consumers, which is correct. All the other ones are talking about plants. Plants are producers and autotrophs. That basically means that they can make their own food from the sun. And then photosynthetic, same thing, can make their food from the sun. Okay, so that's it for Socrative. We will always, like I said, do that starting every single class. So we're going to go ahead and get started now. So I want you to look at these elk right here. And this is how I'm going to tie in scientific method for our new people. And this is how I'm going to tie in our classification for our kids that have already been here a while. So I want you to look at these elk. I love elk. And I want you to type in what are some things you notice about the elk. and try to make them good observations. Think about your classification assignments and what you would say about these animals. What would you kind of use as your like tags and stuff? Okay, good job, guys. For those of you responding in the chat, you can also respond, remember, on this actual joinpd.com. The code is in the upper right-hand corner. Some of you guys are getting super specific. I love it. Short fur, they're tall, they have horns, large spiked horns, they're animals. Sexual dimorphism, meaning that, yeah, the males and females look a little bit different. They have 4 legs. They are definitely alert. They have really huge antlers. Yep, exactly. Those are all very great elk observations. So I want you to think about this for a second. You're a researcher, you're an ecologist, and you're studying how elk populations are different depending on where they live. And elk populations can vary a lot. So think about what would some differences be between an elk population that lives in Flagstaff and an elk population that would live in like northern Canada. So think about same species, different population. So different, we are a different population living in like Arizona than maybe a population that lives over in Asia. So think about that. We're both humans, but we're both slightly different. We have different traits. So what would be some different traits compared to an elk population in Flagstaff and an elk population in northern Canada? Nice. So some of you guys definitely read my mind and have the answer I'm exactly looking for. So what I want us to do is I want us to kind of think back to our scientific method unit, and we're going to write a quick hypothesis. And the trait that I want to use, and like I said, some of you guys in this, when I'm looking at your answers, did a fantastic job answering. So take that now and kind of write it into a hypothesis. But I want you to think of the trait thickness of coat or thickness of fur. And I want you to think about the two different populations, one in northern Arizona or one in Canada. And I want you to write an if-then statement. So if the elk live in Canada, then, or if the elk live in Flagstaff, then, and tell me what you think their coat would be like compared to the other population. Good job. So a lot of you said if the elk live in Canada, then their coats will be much thicker. If the elk live in Flagstaff, then their coat would be less thick as to not overheat. The Canadian elk will have a thicker coat to withstand the cold. That is awesome answers, guys. If they live in Canada, their furs could be darker and thicker. Yeah, because Canadian forests probably are a lot more dense. Probably have a lot more coverage than our forests up in Flagstaff. So, and for those of you that don't live in Flagstaff, I don't know, is anybody not in Arizona that's joining us? I know there's a lot of us are. For those of you that don't know what Flagstaff is, it's northern Arizona, so we have a lot of forests. But yeah, those are great hypotheses, guys. You put an if-then statement and kind of talked about what the difference would be. So questions. If you were to actually do this research and you had to come up with some data, what would you say your independent variable would be and what would your dependent variable be? So the independent variable, remember, is kind of what can change, and the dependent variable is what you are measuring. So the first one is what you can actually change or what is different, kind of. And then the dependent is what you are actually trying to figure out, what you're trying to measure. Good. And remember to be specific. So the first one, remember, is kind of what you can actually manipulate and change and what's changing within the experiment. And what's changing is the location of the elk. So whether the elk be in Canada, Arizona, or in between, that's your independent variable. That's what's changing. And the dependent variable is what you're going to be figuring out about those elk. So what we're trying to figure out about the elk is how thick the coat is. So your dependent variable would be like coat thickness. Is the coat really thick? Is it thin? How much fur do these elk actually have? So make sure that you're always specific when saying what your dependent variable is, because I know a lot of like my students will always say something general, but you have to be specific in what you're actually trying to measure. And in this experiment, we're trying to measure the thickness of the coat of the elk. So this is a really cool picture that I found. This is the range of elk, and I wanted to show you guys this because a lot of you guys are doing your classifications right now with those different biomes, right? Like we're going through the desert, we're going in Antarctica, we're looking in the ocean. And I thought it would be kind of cool to like point out that some of these animals and plants that you're making observations on can be found in different locations. So when we look at an elk, for example, they can be found super north, and look at how north in Canada those go way up. But they also can be really south, and there's Flagstaff down there, and it even goes more south when they get into New Mexico. So just because those elk are the same, they might show up a little bit different based on where they live and where they're located. And because of their location, we really can have a change in what those elk might look like. And a super classic example of this are actually moths. And we'll probably talk about this when we get into evolution again. But these moths are the exact same species. They're peppered moths, but they have changed because of their location. And I think it would be kind of interesting because if you guys were trying to do observation with these animals and look at these two moths, you might not think they're the same species, but these are two different variations of these moths. And what happened a long time ago is most of the moths were white moths. They look like the aspen trees. If you put them up against like aspen bark, they would look just like the aspen bark. But then during the Industrial Revolution, we had a lot of black smoke going into the air. And a lot of the trees became covered in soot. So all the white moths got eaten by birds because they were really easy to spot up against the black trees. So over time, that population changed and more of the moths became black in color. So it's just kind of cool to point out that even though a species can be the same, really depending on their environment, they can often change. So I kind of wanted to point that out as we go on through classification. And this was just a really good way to kind of tie in our scientific method stuff and our new classification stuff. So for those of you that are on the 17-week PACE chart, I sent out the link to schedule your DBAs last week and this week, I believe. So if you need that link, go check your messages in Canvas. It's right there. I sent it out, and I think it's also in the announcements as well. For those of you that just started this week, we aren't scheduling DBAs yet, so don't worry if you're like really confused on what I'm talking about. So those of you that are on the 17-week PACE chart, the gold PACE chart, you need to schedule your DBA with me. We're going to do scientific method and classification stuff. So it shouldn't be too bad, and it'll be awesome. You guys will have a good time. So the last thing that we're going to do, we're going to finish off the lesson is watching human impacts on biodiversity. Throughout this unit, you're looking at a lot of different biomes. You're looking at a lot of different organisms. So I thought it was important because did anybody know that last Friday was World Climate Day? And World Climate Day is basically people coming out and saying, there are some things that are wrong with how we're treating the environment, and it's important to understand what impacts we are having on the world. So I thought we would end it, because World Climate Day just ended, I thought we would end it on a really short video on human impact on biodiversity.
Biodiversity is a variety of life, as we saw in this video. There are thought to be 8.7 million species on planet Earth, and as we saw in this video, biodiversity is of utmost importance to humans. The loss of one key species can have a detrimental impact on many levels, from other species of animals to plants to the physical environment, as shown by wolves. Human activities are reducing biodiversity. Our future depends upon maintaining a good level of biodiversity, and so we need to start taking measures to try and stop the reduction. In this video, we're going to look at how humans are negatively impacting biodiversity. Here are some of the main human-induced threats facing biodiversity. As the world population has grown from 1.5 billion in 1900 to nearly 7.5 billion people today, unsurprisingly, the land use has changed. Habitats have been destroyed in favor of agriculture, forestry, fishing, urbanization, and manufacturing. Unsurprisingly, habitat loss has greatly reduced the species' richness. Habitat fragmentation has also meant that populations have been split into smaller subunits, which then, when faced by challenging circumstances, have not been able to adapt and survive. After habitat loss, overharvesting has had a huge effect on biodiversity. Humans historically exploit plant and animal species for short-term profit. If a resource is profitable, we develop more efficient methods of harvesting it, inevitably depleting the resource, as is currently happening with fishing and logging. The exploited species then needs protection. The difficulty is that the demand then outstrips the supply, and so the resource value rises. This increases the incentive to extract the resource and leads to the final collapse of the population, as happened with whales, elephants, spotted cats, cod, tuna, and many more species. Human activities are polluting the air and water. Toxic discharge into water from industrial processes, unsurprisingly, has a negative effect on local aquatic species by killing, weakening, or affecting their ability to reproduce. Another big water pollution problem is eutrophication, which we'll look at in detail in this video. Phosphorus and nitrogen in fertilizers run off agricultural fields and pass into rivers. These surplus nutrients cause algae to bloom, which then starves other aquatic species of oxygen and light, causing them to die. Acid rain is the consequence of humans polluting the air. This causes lakes and water bodies to become more acidic, killing fish, mollusks, amphibians, and many other species. A huge impact humans have had on planet Earth is the introduction of alien species to habitats. In fact, it is estimated that on any given day there are 3,000 species in transit aboard ocean-going vessels. Alien species can cause problems in a number of ways. Pause the video and have a look. Throughout the Earth's history, there have been periods of rapid climate change that have led to mass extinction events. We are currently in a period of fluctuating climate, but nearly all scientists agree that human activities like burning fossil fuels are speeding up global warming. We don't know how much climate change is going to affect biodiversity in the future, but it is predicted to be huge. Loss of sea ice and ocean acidification are already causing huge reductions in biodiversity. Climate change alters temperature and weather patterns, with changing patterns of rainfall and drought expected to have significant impacts on biodiversity. So there you have a selection of human-related impacts on biodiversity. There are many more, which with a quick search on the internet will bring up.
All right, so like I said, just something to leave off with and think about as you finish up your classification assignments and as some of you start your classification assignments in a few weeks. Okay, so that is it for this week. If you have any questions, go ahead and stick around. If you don't, I will see you next week. Just one thing, I am going to Disneyland this weekend with my friends. We have a 4-day weekend this weekend in my school district that I teach for. So I will be in Disneyland on Monday and I'm coming home Tuesday. So if you message me on Monday or Tuesday, I won't have any access to anything, but I will be having a really great time. So I'll make sure to get back to you guys on Wednesday when I get back. Yes, I love Disneyland and it's Halloween time, so it's always fun. And then I'm gonna go back for my birthday in December too. So it's kind of nice living a car drive away. So thank you guys. I will have a really good time. And like I said, if you have any questions about anything, go ahead and stick around. If not, have a great rest of your day. Have an amazing weekend. And I will see you guys next week.
Hello, Miss Randich. I have a question.
Okay, what's up?
How do we schedule the DBAs?
So I sent a link, and let me see if I can get the link right now, and I can send it to you again. It's through Calendly. Hold on one second. And basically, you just click on this link. Hold on, let me pull it up.
Do you have it on like email? Did you email it to us?
Yes, I emailed it to you guys on
Okay.
Canvas and I believe on your regular one too, but I will send you the link right now in the chat as well. I just had to pull it up.
Okay.
So there's the link, and then it will give you days and times that you can schedule. I think I've had maybe about half of you already scheduled, so there's definitely some times left. But you go ahead and schedule that, and then I will give you a call when you scheduled that time.
Okay, thank you so much.
You're welcome, hun. Have a great day. All right, anybody else? No? All right, well, thanks for joining, guys. Have a great rest of your week, and I'll see you guys later.